Okay, can I quickly ask for your attention for 5 minutes? Okay, now could somebody type into your calculator sine of 20 degrees? And can somebody read out all the numbers which you get on the calculator display?
0.342, 020, 1433.
Okay, now here's my question. Does it stop there? So does sine of 20 stop after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places? No, it doesn't. It's just because your calculator has run out of digits on its display. So in reality, this will carry on going for quite a long time. Okay. However, if you type something like this in, sine of 30 degrees, in fact, we've already done this one. Yeah, it should be 0.5. It's a half. Okay, 0.5. So this is interesting. Sometimes if you type sine of a particular angle in, it doesn't come out as a nice number. It comes out as a horrible long number that is probably irrational. Sometimes when you type an angle in, it comes out as a nice number. And in fact, there's 5 instances which you need to be aware of where sine, cos and tan comes out as a nice number, 5 angles. And they are 0, 30, 45, 60 and 90. Okay? So what I'm going to give you is a way of learning these 5 angles, because effectively you would need 15 different numbers to remember, okay, and remember where they go in this table. So we're going to create this table here, okay, and we can do it through a calculator, okay, so for example we can already fill one in, sine of 30, that's 0.5 or 1 over 2, okay, a half, okay. Does anybody know what the cos of 30 is?
The square root 3 over 2.
Yeah, good, and so on. I could carry on and ask you the rest. But what I want to give you is a way of kind of getting these 5 angles, the sine, cos and tan of these 5 angles, without having to rely on, well, memory or without having to rely on a calculator. Okay. Now, conveniently, there are 5 angles, and on your hand there are 5 fingers. Okay. So what I'm going to do is I am going to assign each finger a different angle. Okay, and it makes sense to start with 0 over here, and the next one be 30, next one be 45, your 4th finger would be 60 degrees, and then your last middle finger would be 90 degrees. Okay, so it just works across there like that. Does that make sense? It doesn't really matter where I put them, but it doesn't really matter whether I start 0 here or here, but it makes sense to put them in order. Okay, now here is the idea. If I want to find the sine or the cos of a particular angle, I would put that finger down. Okay, so for example, if I wanted to find the sine or cos of 30, I would put that finger down. So that's my 30 finger, so I put that finger down. Okay, and then you notice that on this side of the finger which is down, there's 1 finger which is up, and on this side of the finger which is down, there is 3 fingers which are up. Okay, so one of them corresponds to sine, and one of them corresponds to cos. Okay. We'll worry about tan in just a second. So, if I'm working from the left, in other words, I'm working in this direction, so I'm looking at all the fingers which are up on the left of the finger which is down, okay, I am working with sine. I'm working with sine. If I'm working in the other direction, so in other words, I'm looking at the fingers which are up on the left-hand side, I am working with cos. Okay. Now, I'll just give you a way which I remember this, because sometimes I have to think about it as well. Do you notice that this arrowhead, if I kind of curve this arrowhead around, would you be happy that that looks like a C? Okay, that looks like a C. Whereas if I curve this arrowhead around, the C is the wrong way round, so it can't be C. Okay, so I just remember that because this arrowhead, when I curve it round, looks like a C in the right direction, that must correspond to the C of cos. Okay, so that's the way which I remember it. So, here's the rule. Basically, I root the fingers which are up and I stick it over 2. Simple as that. So let's give this a go. I'm going to put my 30-degree finger down. So I want to find the sine and cos of 30. I want to verify that that works. Okay. So I'm going to put my 30-degree finger down. Okay. Now, if I want to find the sine, it means I must work in this direction. So I must look at all the fingers which are up on the left-hand side of the finger which is down. How many fingers are up on the left-hand side of the finger which is down? 1, okay? So I should square root that 1. What's square root of 1? 1. And I should stick it over 2. So I get 1 over 2 or 1/2. Does that make sense? Yeah. If I want to just check for cos, well, cos now is working in the other direction. So if I'm working in this direction, how many fingers are up?
3.
It's 3, okay? So I should square root that 3. Can't simplify that at all. That's just square root of 3. Stick it over 2. I get my root 3 over 2. Does that make sense?
I think it would be it would be easier if I could just remember it.
If you just want to remember it, that's fine. I'm just giving you another way to do it. Yeah? Okay, good. So could you try the sine of 60 for me? With the fingers, if you're whatever way you want.
Sine is square root 3 over 2.
Okay.
Cos is 1 over 2, and tan is square root 3 over square root 6 over 3. 3 over 3.
3 over 2.
It's well. Hang on a minute. Hang on, lots of people are calling things out. I'll come to the tan in just a second. Okay. Just stick with sine and cos.
Yeah, square root 3 over 2.
Did you just stick it in a calculator? Come on.
I
Like.
tried it at first and I tried with the hand.
Okay, so do it with your hand then. Let's do the practice. Put your 60-degree finger down. That's your fourth one. That's your fourth one.
So I use 3 hands and 6 square root 3 over 2.
So sine is on this side. There's 3 fingers which are up, so I should square root that 3 and stick it over 2. Okay? Whereas if I'm looking at cos, I'm working in that direction. How many fingers are up? 1. Square root that 1, stick it over 2. I get my half. Okay? My half. Now just pause for a second because that's interesting. Do you notice that sine and cos swap over for 30 and 60 degrees? Can anybody give me a reason why that makes sense?
Because 30 plus 60 equals 90.
Good. So if you remember, exactly, if you remember what I was saying at the start, Megan, can I just... If you remember what I was saying at the start, okay, imagine I was looking at this angle down here. Imagine this was my 30 degrees, okay? Well, in this case, would you be happy that would be my opposite and that would be my adjacent? And clearly that's going to be my hypotenuse, okay? That's going to be my hypotenuse. Which means that if sine of 30, just remind me, what is sine of 30 again? It's a half. So that could mean that that is 1, okay? And that is 2, okay? And that is 2. In which case that would have to be root 3. Just think about Pythagoras there, yeah? Well, okay, if I then swap this over, so I look at this angle up here, what has that angle got to be? It's got to be 60. It's got to add up to 90 because one of the 90s is already gone, okay? Well, if that's the angle I'm interested in, this side is no longer the adjacent, is it? It's the what? It's the opposite. So now the opposite is root 3, and this must be the adjacent, which is now 1, okay? So do you see that by looking at the different angles, 30 and 60, because they add up to 90, then the adjacent and the opposite will swap over depending on which one I'm looking at. So if I'm looking at sine, I'll be using this side and this side, which is 1 over 2, okay? But that should be equal to the cos of 60, which is also 1 over 2, okay? Because those sides are swapping over, okay? Now, interestingly, has anybody ever thought, so if I write out sine, okay, so that's the word for sine, and if I write out cosine, has anybody ever thought, why are these two words really similar? So one's sine and one is cosine. What does the co bit mean that changes it from this? What does the co bit mean? Does anybody know? It stands for the complement, okay? Now, not complement with an I, in other words, your hair looks nice. Complement with an E means it goes together with, okay? And in general, with angles, if angles are complementary,
It's 180.
that's supplementary, yeah? So complementary means that they have to add up to 90 degrees. So you can see why sine and cosine are complementary of each other, because if you look in your right-angled triangle, your sine will be so let's say, for example, we're looking down here, your sine of 30 should be equal to your cosine of 60, because 30 plus 60 adds up to 90. Okay, does that make sense? Yeah? So sine and cosine, the reason why they have the similar names, the co of cosine simply means it's the complement of sine. In other words, those two angles have to add up to 90 in order to get the same thing. Okay? Okay, so just fill in the rest for me. What would the sine of 45 be?
Square root of 2.
Square root of 2 over 2. What would the cos of 45 be? Square root of 2 over 2. Okay. What would the sine of 0 be?
1.
That would just be,
1.
it would just be 0.
Oh.
Check it, because you put your 0th finger down, you're looking at the number of fingers which are up on this side. How many fingers are up? None. So it's going to be square root of 0, still 0. Divide that by 2, still 0. So it's got to be 0. Okay. But if you look at cos, you notice that there are 4 fingers up on the right-hand side. What's square root of 4? 2. 2 divided by 2 is 1. Okay. What would the sine of 90 be?
1, 0.
And 0, because you notice they cross over. Yeah, good. Now you notice that we haven't looked at tan. We haven't looked at tan at all. Now tan, just by identity, I'm not going to prove it to you actually. So tan should just be equal to sine over cos. It's not very difficult. It's just using Pythagoras and actually just using the unit circle. We will come to that in a few themes time, but I'm not going to introduce it now. So basically, in order to get tan, you just need to take whatever sine is and divide it by cos. For example, if you wanted to find the tan of 0, you would take the sine of 0, which is 0, and divide it by the cos of 0, which is 1. What's 0 divided by 1?
0. No. Wait.
0.
0 divided amongst one person, that person gets nothing. Yeah? Okay, what's a half divided by root 3 over 2?
Square root 3 over 3.
3 over 4.
Over 3.
Oh wait, it's 2 over square root 2 square root 3. Never mind.
Good, let's just quickly check that just to make sure. So we take 1 over 2, so tan of 30 should be equal to sine of 30 divided by cos of 30. Well, okay, that should be the same as 1 over 2, that's the sine of 30, divided by the cos of 30, which is root 3 over 2. You're familiar with fractions, right? You should just multiply by the reciprocal. So you get 1 over root 3, because the 2's cancel. And of course, you can rationalise this denominator, multiply by root 3 on the numerator and denominator. That should give me root 3 over 3. Do you see that? Yeah? Okay, so that's root 3 over 3. What's that one?
1.
It's 1 because you're dividing by the same thing. What's this one?
Square root 3.
Square root 3. What's this one?
It doesn't exist.
Yeah, you can say plus or minus infinity if you know what you're doing, but I would just put undefined. Okay? Because you can't divide something by 0. Okay? So Riley, if you've just memorized that table and you're familiar with that, fine. Okay? And the more practice you can do with this, then that's great. But if you're not sure and if you're still getting so used to these things, that is a way of working with this. That is a way of working with this. So stop relying on the calculator all the time. The calculator is there as an aid for you, but if you can familiarise yourselves with things like this, because there are situations where you don't have a calculator in front of you, that's useful. That's useful.